Lesson number 3, Satellites. To understand the idea of launching the satellite, imagine that when projecting a cannon projectile from the top of a mountain in a horizontal direction, the projectile moves through a certain horizontal distance before falling on the ground. By increasing the velocity of projection, the horizontal distance moved by projectile before falling will increase. By increase the velocity of projection, the distance moved by projectile before falling on the ground will increase. At a certain projecting velocity, when the curvature of projectile equals the curvature of the Earth's surface, the projectile orbits the Earth in a circular path, and it becomes a follower of the Earth and named a satellite. This velocity is called the orbital velocity of satellites. So what is meant by the orbital velocity of satellite? The velocity that makes satellite rotate around the Earth in circular path at a constant distance from the Earth's surface. What happens when the satellite stops and its velocity becomes zero? Of course, it will fall in a straight line toward the center of Earth and fall on it. If the gravitational force between the Earth and the satellite vanish equals zero, the satellite moves in a straight line along the tangent to the circular path and move away from the Earth. How to find the orbital velocity of the satellite? V, orbital velocity equal square root g m over r. G, gravitational constant, m, mass of planet, over r is the distance between satellite and center of Earth or center of any planet. So r equal r capital radius of Earth or radius of any planet plus height of satellite. Also, there is another law to find velocity, 2 pi r over t. T is periodic time. The velocity of satellite in the orbit doesn't depend on its mass, but it depends on the following factors. Number one, mass of planet, not mass of satellite, mass of planet. Number two, the height of satellite away from the center of planet. Try to answer this example to check your understanding. Test yourself. A satellite orbits the Earth in a constant orbit if a part that represents quarter the mass of the satellite separates from the satellite. Then the orbital velocity of the satellite, of course, it will remain constant. Because what? Because the velocity doesn't depend on the mass of satellite, depend on mass of planet, not satellite. So the velocity of the satellite will remain constant. I hope you understand this lesson. Thank you and goodbye.